The Open Source Hardware Enterprise, or OSHE as we call it, aims to add value to the open source community through our research and our projects. Our projects and processes follow the open source standards and values of affordability, replicability, and accessibility. The projects developed in OSHE fall into three main categories: consumer, manufacturing, and research projects. The three projects that we have to present today represent these categories. Thunniform Robot is a research project working off a pre-existing open source project to design a non-invasive analysis tool. RecycleBot is a manufacturing-based project that aims to add value to the open source environmental manufacturing space by providing an extrusion platform for recycling. And Synthesizer is a consumer project focused on lowering the barrier of entry to DIY synths. Here are the teams to tell you more about their projects.
RecycleBot is a project developed to process virgin resin or recycled 3D printer waste into new 3D print filament and represents the manufacturing side of OSHE. The project's goal is to produce a filament at 1.75 millimeter diameter with a tolerance of plus or minus 0.05 millimeters. This is accomplished by three main units. The extrusion unit uses a purpose-built extrusion screw and barrel with 3 heating zones to provide a consistent flow and proper melt profile. The cooling unit uses a fan bank to bring the filament back down in temperature. This fan bank also provides a chance for inspection of the filament during production. The rewind unit uses an infidel sensor, which is a magnet-driven gauge sensor, to read the diameter of the filament. This signal is used to control the speed of the spooling unit to control the diameter of the filament. The rewinder will speed up to increase draw for materials too thick and vice versa for materials too thin. Our rewinder incorporates bread into the control scheme, which is another OSHE initiative to drive the motor and log the diameter readings for further analysis. RecycleBot has successfully been able to produce filament with virgin resin and 25% recycled material by weight, which is a green-colored filament seen in this video.
The Synthesizer project aims to design and prototype an open-source subtractive synthesizer that's much more affordable and modifiable than commercially available instruments, which can cost thousands of dollars to tens of thousands of dollars and limit customization.
Our design revolves around utilizing the extensive digital signal processing capabilities of the ARM Cortex M7 processor on the Teensy 4.1 microcontroller to create a synthesizer with 2 multi-waveform oscillators, a low-pass filter, an amplitude envelope, and 8 voice polyphony.
Our design process involved creating a modular digital design of the instrument, programming the microcontroller, PCB design to connect all electrical controls and power circuitry to the microcontroller, and finally a physical enclosure design.
We are going.
The Thunniform Robot team has been working to build off of the existing OpenFish project to create a flexible, biomimetic platform for sensing and observing in an underwater environment. Several improvements were made to the original design, including a modified tail motion system to improve performance, reduce cost, and allow for turning. A new seal design was developed to provide a better and more reliable seal in the body of the robot, and the body design was scaled up. In addition to redesigning some portions of the OpenFish project, several new systems were added, including a battery, buoyancy control system, a variety of sensors, and an option for wireless control. To implement these features, a Raspberry Pi running ROS2 was used, and a custom Raspberry Pi hat was developed to interface with the sensors, motors, and battery. Buoyancy control was implemented using a syringe that can pull in about 225 milliliters of water, changing the weight of the robot enough for it to move vertically underwater. A temperature sensor, IMU, and stereoscopic camera were included in the robot with provisions to add a pressure sensor. The electronic system was designed to be as flexible as possible, so more sensors can be added with relative ease. The OpenFish project required a tether to power and control the tail motor. In order to eliminate the need for a tether, the Thunniform Robot team developed an acoustic wireless communication system that allows for commands to be sent to the fish and for data to be sent back to the controller. In addition, an Ethernet cable can be used as a tether to allow for faster data transfer and lower latency control of the robot.